Hi, I'm Michel Dufresne. This is a two-part presentation on Top Engine. Please see my blog at blog.dufresneconsulting.com for more information on Top Engine and how we can use semantic web technologies for business rules application. On the first part, I'll describe Top Engine and how it can make life easier for developers. On the second part, I'll do a demonstration where I'll use the interview engine, which extend Top Engine to using tagging techniques to express knowledge and business rules. Top Engine is a business rule engine that uses the web ontology language to define the domain models and allows to write rules on top of the ontology using the ontological definitions for the vocabulary primitive of the business rules. It's an inference engine written in C++ using an optimized Rete-based algorithm with forward and backward chaining and also has querying capability in a SparkQL-like syntax. The underlying domain model is represented as an RDF graph, and also Top Engine generate proxy classes in Python and Java from the ontology that provides access to the RDF graph without having to know all of the details of RDF. Top Engine goes beyond traditional business rule engine, where it uses tagging techniques to extend the ontology and define rules. That will be presented on the second part. The web ontology language is a W3C standards that allows to build classes and properties using description logic. More on this on my blog at blog.dufresneconsulting.com, where I have a three-part presentation of titled Rules and the Semantic Web that allows how to write rules on top of ontologies. There's two core problems that Top Engine try to solve. One is to reduce complexity in web-based business application by providing a separation of concerns between the domain model and the web application technology used for constructing the applications. Also, power user can write simple rules using tagging techniques for expressing the rules. That will be presented on the second part. So here's an example of writing rules on top of ontologies. You would first import the ontology into Top Engine, where Top Engine can be used as a LDL reasoner to ensure consistency of the model and also to compute the inferred class hierarchy. For example, let's say you have a class adult that's defined with a class expression that says an adult are the persons and the individual that has an age group of a value of type age group 21 to 64. Age group is a value partition that has three partitions. Top Engine would generate a rule from this class expressions that would say for every individuals of type person that has an age group which is of type age group 21 to 64, then the person must also be of type adult. Additional rules can be expressed. The previous rules we just saw is generated automatically from the ontology, while we could express additional rules that would say, for example, for an individual of type person that has an age that falls between 20 and 65, then the person has an age group of an individual of type age group 21 to 64. So with those two rules, we express the domain model using RDF. So let's say, for example, you have two triples, one that says the individual Smith is of type person and Smith has age 34. Then using the last rules with the age of 34, it would infer that the age group of Smith is of type age group 21 to 64, and that in turn would use the rule generated from the ontology to infer that Smith is also of type adults. So here we have an example where you have rules that comes from the ontology and as well as rules that have been written on top of the ontology to infer information. A domain model can be generated from the ontology, so we don't have to use the RDF API directly, which makes things much easier for web developers. For example, you could create an instance Smith of type person using a factory create person, and then you could set the age 34. Then you would call the infer on the model, which will compute and apply all of the rules on the asserted information. And then you could check if Smith is of type adult, and if so, you could get an interface of type adult to Smith, and then do stuff appropriate for adults. Then we created initially an individual of type person, which is of general type, and then through classification, we were able to cast down to a more specific type of type adult. This is not generally available in object-oriented. Usually in object-oriented, you would have to create instance of the most specific type, here of type adult, in order to get an interface of type person or adult. Also, Top Engine allows you to do query in a way that is similar to relational databases, in which the result set is a tabular value of is returned in a tabular value. So, for example, if you would do a query of person, age group, and zip, where you have the expression here, that's the joints across the RDF graph, and this query is defined in a rule file, then by invoking this query, you would get a result set in a tabular fashion, for which all the information is returned as columns here. The advantage of this approach is that some of the columns could be asserted information, while other columns could be inferred information, and that is presented uniformly as a single tabular fashion and transparently to the web application developer. So this concludes the first part of the presentation. You could have more information on my blog, and please watch the second part where I do a demonstration of the interview engine. Thank you.